Good morning, children. So these are the numericals of exercise 2C. Okay. So I have solved the numericals, but I will suggest you to listen to the lecture, listen to the tips that I am telling you, how to solve the numericals, and first try solving them yourself. Okay. First, don't see the solution, otherwise it will be of no use for you all. Okay. Try solving the questions yourself. Whenever you do the numericals, first of all write whatever is given in the numerical. Read the numerical carefully and write whatever is given in the numerical, the given values. That will be a great hint for you to solve the numericals further. Okay, so I have marked some of them to explain to you all. See question number 3. A vehicle is accelerating on a straight road. Its velocity at any instant is 30 km per hour. That means u is given to you. Okay, see, I have also written the given values first. Okay, so u is given to you. After 2 seconds, that means t is given to you. It is 33.6 km per hour. So v is given to you. What is happening? Initially the velocity was this. After 2 seconds, this became this. Okay, so you can, and after 2 seconds, now see again, after 2 seconds the velocity became 37.2. that means for the next part of the journey u will be 33.6 km per hour and v will be this much, right? And t will be 2 seconds. So what is the question? Find the acceleration, and you have to tell whether the acceleration is uniform or not. So now v is given, u is given, t is given. We have to find out a. That means we have to apply the equation v is equal to u plus at. So on applying, we solve it and get this. And for the next part of the journey, we again apply the same formula and get the answer. Because both of these answers, this one 0.5 and this one is same, that means the acceleration is uniform, right? See question number 5 now. A bullet initially moving with a velocity 20 meter per second. Initially moving, that means u is given to you, right? So u I have written. Strikes a target and comes to rest. Comes to rest. This is a big hint. You have to read the question carefully. Comes to rest. That means v is equal to 0. After penetrating a distance 10 centimeter. So distance is given. S is given 10 centimeter, but because this was in meter per second, we are converting centimeter into meter. Okay. Calculate the retardation. So retardation we have to calculate. That means in a way we have to calculate A. Now V is given, U is given, A you have to find out, S is given. That means the relation, this way V, U, A and S all are coming. That is V square is equal to U square plus 2AS. So put all the values. A comes out to be minus 2000 meter per second square. This minus sign shows that this is retardation. Now when you have to write, either you say the acceleration was minus 2000 meter per second square, or you say retardation was 2000 meter per second square. Don't ever say that acceleration is 2000 meter per second square for this problem, or don't ever say that retardation is minus 2000 meter per second square. As soon as you write it retardation here, the minus sign should be removed. This is very important, otherwise your marks will be deducted. Then see 11th problem, or let us see the 11th problem. So a body moves from rest with a uniform acceleration. A body moves from rest, that means u is equal to 0 with a uniform acceleration. So a we don't know, okay, and travels 2 centimeter in 3 seconds. So s is given, t is given, a don't know. You have to find the velocity of the body at 10 seconds after the start. So first we want to find out a. So see, when these things are given, you can apply this equation only. So we will calculate a. Then we have to find out v after 10 seconds. So when you have already obtained A, U is given to you, T is given to you, V is equal to U plus AT, and you'll get the answer. And see the 12th one, a body moving with a constant acceleration travels the distances 3 meter and 8 meter respectively in 1 second and 2 seconds. Calculate the initial velocity and acceleration. So A is given. There are two things given to you. S is equal to 3 meter for T is equal to 1 second. Then this. So let us see the first one. S is given, T is given, U and A you have to find out. So we'll apply this formula, put the values, and we get an equation like this. A is equal to 6 minus 2U. Then take the other values, put those values, and you'll get an equation like this. Here in place of A, we are putting the value we had obtained here, 6 minus 2U. In place of that, you put this value, you solve it, you'll get the answer. I don't know if you have learned solving equations having two variables in mathematics or not. If you have learned it, then it will be easier for you. Otherwise, just try doing it, practice it. I've told you what you have to do. Then see question number 14. A spacecraft flying in a straight course with a velocity 75 km per second. That means you are given U. 14th one. Okay, that means U is given to you. Then it fires its rocket motors for 6 seconds. Okay, T is given. At the end of this time, its speed is 120 meter per second. So kilometer per second, sorry. So V is given, right? Let me put it here. So V is given. So when U, V, T, all the things are given, V is equal to U plus AT, and you can calculate A from here. Now see, ideally we find out, we put the unit as meter per second, but here it was given kilometer per second. So we have taken it as kilometer per second square. Okay. Then at the end of this time, its speed is this much. Okay. Find the spacecraft's average acceleration that we have done. The distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started, the motors having been in action for only 6 seconds. Now see, when the motor was started, it was kept started for 6 seconds, and after 6 seconds it was stopped. That means the aircraft will be accelerated only for 6 seconds. After 6 seconds, it will have a constant velocity. It won't be accelerated, and neither the brakes are applied. Okay. That means it will have a constant velocity, whatever velocity it has attained after 6 seconds. So after 6 seconds, the question itself says that it was having a velocity 120 km per second. Okay, that means for 6 seconds the motion was accelerated. Out of the 10 seconds, the first 6 seconds the motion was accelerated, and the rest of the 4 seconds it was unaccelerated motion, right? So for the first 6 seconds, see, we can apply this equation ut plus half at square. U is given in the question, and when you solve, you will get this. Okay. And after 6 seconds, the motor was stopped. That means it was having a constant velocity. Whenever a body is having a constant velocity, we can simply write that distance traveled is equal to velocity into time. So velocity, now the velocity will be the last velocity, the final velocity that was attained during the accelerated period of 6 seconds, right? So the velocity obtained was 120 kilometer per second. That is given the question itself into 4. So when you add both of these values, you get this much, right? Just see these numericals like a story, and just you can read it again and again, and it will surely come into your mind. See, the questions themselves have the solutions. They themselves give you the biggest hints. So read the question again and again if you are missing something. Okay. Now see question number 15. A train starts from rest and accelerates uniformly. Now see again, starts from rest. This is a big hint. U is equal to 0 and accelerates uniformly at a rate of this much. So acceleration पता हो गया. Now for 10 seconds, okay, t is also given. So u is given to you, t is given to you, and a is given to you. Okay, it then maintains a constant speed for 200 seconds. See what is happening. A train starts from rest. See, the train is starting from rest. Okay, it is starting from rest and accelerates uniformly at a rate of 2 meter per second square for 10 seconds. Only for 10 seconds it is accelerated, right? Can you see here? Only for 10 seconds. And then from here, from this point, it is having a constant velocity for 200 seconds. Then whatever velocity it has obtained at this point, that velocity will be carried on for this period of time, 200 seconds. Then here the brakes are applied. Okay, यहाँ पे brakes are applied. Okay, and then they say, and then the train is uniformly retarded and comes to rest in 50 seconds. So it comes to rest in 50 seconds. So after 50 seconds, its velocity becomes 0. Can you see it here? It is clear now. So v is equal to 0. So for 10 seconds it was having an accelerated motion. Here u was 0. Initially it was starting from rest. It might have obtained some velocity. Then it was having a constant velocity throughout this period. So throughout this period the velocity will be v. Then at this point here also the velocity still here will remain to be the same. Okay, and then here brakes were applied and the final velocity is u. So for this part of the journey, this v will become the u. Okay, so let us see. I have solved it. So okay, so first we need to find out the velocity which it obtained after 10 seconds. Okay, so 20 meter per second. And here only I have the next part of the question says you have to calculate the distance in the throughout the journey, right? So I have calculated the distance traveled in 10 seconds here only. So s is equal to ut plus half at square, and you put the values. So this will give you the distance traveled in 10 seconds. Why are we applying this formula? Because here the motion was accelerated, right? Now after this, for 200 seconds the motion was unaccelerated. That is, it was having a constant speed. Which speed? The speed it had obtained after 10 seconds, right? So 20 meter per second. Now constant speed means distance is equal to speed into time. So 20 into 200, this will come out. Okay, now brakes are applied. So when brakes are applied, this v will become the u for that part of the journey, right? This is the initial velocity for that part of the journey. And then t is equal to 50 seconds. Final velocity is 0 because it is coming to rest. So put the values and you'll get the retardation as 0.5 meter per second square. That is asked in the question. And distance traveled in these 50 seconds. Now here again the motion is retarded. Okay, so we need this formula. We'll put the values, get the answer. So total distance traveled is, see, 100 meter here, then 4000 meters here, and then 500 meters here. So adding all of them we get this. Then average velocity is always average velocity. Don't ever calculate the average velocity by adding all the velocities and dividing it by the number. No, you don't have to do that. Average velocity here will be calculated as, here means the actual formula for average velocity is total distance upon total time. So the total distance was this, we have calculated, and total time you can see in the question. First they are talking about 10 seconds, then 200 seconds, 50 seconds. Write all the values, add them, and you'll get this answer. Okay, so some of the questions which were the selected ones, and I felt that you will be having problems, so I have discussed those with you, and I'm telling you again and again, for doing the rest of the questions, keep in mind that you have to read the problem thoroughly, because the problem itself has got the answers. Okay, this is the wonder for life also, right? Problem itself has the answers. So read the question again and again, you will get the answer, get the hints over there. Write the given values. Okay, read the question like a story. It is telling you something, each and every part of it is telling you something. So read it, write the given values, see whatever given from the given values, that which equation you can apply over there. Okay, and then I have given the solutions so you can see them. But if you do the questions yourself, that will be good to you only. Okay, that will be very good for you, that will be helpful in higher classes also. Okay, so please do the numericals yourself. Thank you. Bye bye.